Hi, I'm Kajul Singh. Welcome to ITILC, Industrial Training Institute Learning Corner. Now today's class is the DC machines. We are going to study about the DC machines. What do you mean by DC machine means? If we give direct current supply to the machine, it acts as a motor. And when it is driven with a prime mover, it gives out the DC source. That means it acts as a DC generator. That's why it is known as DC machine. So what are the principal parts of a DC machines? That means first of all we have to study about the what are the components that are fixed or mounted on DC practical machines. So what do the practical machines means? That means it gives the DC source or a DC output when it is driven with the prime mover, whether it can be diesel engine or petrol engine or kerosene engine used as a prime mover, or sometimes it is driven with the squirrel cage induction motor. That means AC supply is given to that means squirrel cage induction motor, and it is connected with the DC source. So DC machines, so it is a DC machines, so it acts as a DC generator. We can take out as the DC power. If we give DC AC power as 400 volt, the DC the 400 volt AC motor, and it will give out about the 250 volt pure DC, and the wattage is transmitted with respect to the efficiency of the machines. So now we are going to study about the components. What are the principal parts of the DC machines? First of all, we have to study the motor body, that means machine body made with a silicon alloy steel. Why does it made with that? The reason is it passes a magnetic field easily, so the magnetic permeability is very good in silicon alloy steel. That means silicon alloy cast iron. The motor body is made with a silicon alloy cast iron. The permeability of the silicon alloy cast iron is very good, and it acts as a motor body. And second one is it is the rotor. That means the armature. The armature means actually the armature unit is rotating inside the magnetic field. That means rotor content with the commutator. That means when the voltage is induced in conductors, it is taken out through the commutators and the support of the graphite brushes. That means carbon brushes. We can take out the DC power. And another one is what is the magnetic field? That means it is the magnetic field is produced in the field coil itself. That means the main field coil in shunt generator. The field coil is connected parallel with the rotor, that means armature, and in this fashion, if it is connected, that is known as shunt motor. And the prime mover is driven with the machine. That means when prime mover, whether it is DC, whether the AC source, that means it is connected with the squirrel cage induction motor, and armature is when it is connected with that is rotated inside the magnetic field that produced by the field coil, and it gives out the DC power. So it is known as a DC generator. By symbolically we can represent what is armature and a graphite brush and the field coil and its connection diagram using like this. First of all, we have to study about the armature conductor. This one is armature. That means rotor. The rotor, that means it's rotor. And this one is the graphite brush. This one is known as a graphite brush. And another one is it is called the field coil, that mainly used to produce magnetic field. This one is field coil. This is represented like this. And the prime mover is attached with the rotor, and so that it rotates prime mover. And when it is connected, the rotor is when it is connected parallel to the field coil, just like this. ball coil, and it is give out a DC source. That means DC power like this. So this one is known as the one is graphite brush, carbon graphite brush, and this one is known as field coil. Field coil means it produces magnetic flux for the requirement of the production of the EMF, electromotive force, in the generator, like this. And this one is the rotor. That means this one is known as rotor, armature. That is armature. Armature means conduct with mainly the armature conductors. So many copper conductors are there, and the copper conductor, while rotating inside the magnetic field, EMF is induced according to the Faraday law of electromotive force. That means whenever the conductor cuts the magnetic field, EMF is induced in this conductor, that is taken out through the commutator and the supporter graphite brush, which we will get the DC supply. This is the generator. This one is called a DC generator because the machine is operated with the prime mover. The prime mover can be, that I already have told, that means a kerosene engine or petrol engine, diesel engine, or AC squirrel generation motor, anything else. This one is known as the DC machine. Thank you. I hope you have understood that topic. Hi, I'm Kanju Sen. Welcome to Industrial Training Institute Learning Corner. Now we are going to study about the DC motor following the DC generator. That already I gave the instruction, what explanation about the DC generator. Now we are going to study about the study about the DC motor. Already I gave the explanation regarding the DC generator. Now the same machine can be operated as a DC motor. But the DC motor, if it is to be operated, it required additional accessories, just like the starter. So I give explanations regarding this. Like this one is the armature, and this one the field coil, and when the generator is this one a shunt generator. This one is called shunt motor. We are going to study about the shunt motor, DC shunt motor. And the shunt motor, the behavior of shunt motor is the rated power, it gives out the constant RPM. Theoretically, there will be some fluctuations according to practical difficulties. Most probably, it will give the constant RPM at a definite power. Now, if you want to connect the DC source with the motor, it requires some accessory that is known as a starter. We need 3-point starter is to be connected with the motor. The reason is that when we connect these 250 or 230 volt to the motor, the armature resistance can be 1 ohm to 2 ohm respectively. When it is connected parallel, if this 200 volt is given, according to Ohm's law, that means the current is equal to voltage divided by current resistance. That means 200 divided by 2, that become approximately 100 ampere. The 100 ampere, when it is converted into according to Joule's law, that means Q, a quantity of heat produced, is equal to I square R into time and seconds. So that it gives in 1 second I squared R means 100 into 100 into 2 ohms. That nearly, that gives that is 10,000 into 2 means 20,000 joule immediately. That if it is source is able to provide, that means 20,000 joule of heat, it will immediately, the armature conductor will got short circuited. So in practical way, it is not impossible to operate it. That's why we have to give some assistance to start the motor. That means the 3-point starter. What is 3-point starter means? What 3-point starter means? The resistance is seriously connected with the armature. So that I give this some example. This one is, if it is the given with the resistance if the resistance connected to the series with the armature is given initially less current. Then after getting the repeated speed, that means a stipulated speed, that means fixed speed, the back EMF is produced. According to law of electromagnetic induction, that means when the conductor rotates inside the magnetic field, the back EMF is produced. Till then, the voltage must not be given in full rate with the armature. That's why we give some resistance. So this one is called this is the protection of the motor on starting purposes. So that we use some technique to start the motor. We use generally a 3-point starter. That means 3-point starter means, we know that what is 3-point starter means. I'll give some easy way to understand that. This one is known as 3-point starter. That is L, armature and field. There are 3 points. If we operate with these 3-point starter with the dipole switch, DC is given the dipole switch, the line, this positive terminal is straightly connected with the line, and armature, that means the line and armature, in between there will be resistance, what I previously drawn it. That means it is straight connected with the armature. So the armature is connected with the resistance that provided inside the starter. Again, the field coil, that is given parallel to this. The line is straight, that means parallel. That means full voltage is given according to this purpose. This one is connected to field coil. This can be the full, even the resistance of the starter, that is actually really acted with the most probably acting with the armature, and some resistance is acting with the field coil, not fully acting with the partially, the resistance also acting with the field coil. Accordingly, the connections were given. Next one is and both the points are joined together. That means it is independent, and this negative is joined like this. Then we will get the motor is to be get started, and we can work. This is straightly connected. The armature rotor is directly connected with the mechanical load, and we can use it when the supply is cut off, or when the main switch is off. The starter position, that means we return to normal, that means off position. That means that the handle which will reflect, that means that will come to the original point. After that means I will give some the detail about the 3-point starter inside the detail regarding 3-point starter in class later. Thank you. I hope I would have understood.